That's how quick it is to muck a bucket.
Alright, so we got our two 300-pound samples from the vein. Crushing those right here in front of me. We're gonna run them through twice, and then later today we're gonna cube and sluice them to see if we got any free milling gold in this material. So here you can see we have some gang rock. This brown is hematite. So the iron banding in hematite is some of it's oxidized pyrite, and underneath that we have more heavily oxidized pyrites, hematites, iron ore, and hopefully a little bit of gold. This hard rock gold is so wiry, kind of crystalline, flat, what have you. It really does not want to sink through these black sands. That's a disc of gold right there. So our cons from the top tray are beyond impossible to pan. This is probably the most challenging stuff I've ever panned. Every little speck down in here that's glowing is gold, and we have a line of gold up there at the top. So I think what we're gonna do is we're gonna super upgrade our cons even further and do a smelt on this material to see what we're actually getting. So here we got hard rock sample number 2. Got a bunch of gold in there. It's super fine. There may or may not be more in this than the first batch. We'll have to smelt it and see. But all that up there in the top, it's a nice little pile of gold. All right guys, it's assay time. This is sample number 2 from the mine that we chiseled out the other day. We concentrated, upgraded. Trying something new here. You can see the flux is black. This is a Chapman flux recipe. We're gonna see how this does on the ore here. We're gonna load it up into the furnace. We're gonna fire it up, smelt it, stir it, pour it, coupel our button, see what kind of precious metal button we're left with. All right, let's warm up the furnace. It's pretty cold out here today, so we're gonna bring up the furnace. We're gonna bring the furnace up to temp pretty slowly. Same with the crucible and our assay. There we go. Looks like the smelt stopped boiling. We're gonna kick it up to full blast for a couple minutes. Gonna warm up the mold. Pour time! we're gonna put it back in the furnace. Let it cool nice and slowly. While the pour cools, we're gonna warm up the coupelling furnace. Right here, we've got the coupel inside so it can dry and preheat. Once we get the button, we're gonna load it in here, coupel it down, and get a precious metal bead. Here's our button. So we're gonna clean that up. The lead definitely looks different, so I believe there's some precious metals in it. So we're gonna clean that up, get in the coupel, and coupel it down. We're up to temp, the coupel's nice and dried out. Now let's load the button. So here we have it. Close her up. Now on to round 2. We're gonna load up the crucible again with sample number 1. We have a larger volume, so we're probably gonna use a bigger crucible. We're gonna get that loaded up and smelting while this is coupelling, and hope for a nice big go button. For this last final smelt, we're going to use the number 10 salamander crucible. I got it here drying out, getting ready. Put a little bone ash on the bottom of the furnace to absorb a little bit of a boil over I had on the previous smelt. Now we're going to load this baby up. And as you can see, we're less than half full. So I'm really hoping when we have the reaction between the flux and the ore concentrates that it will not bubble up and rise past the rim here. 20 degrees out here, freezing cold. Still got work to do. It looks like the slag, it's not glowing at all red anymore, so I'm going to try to release it. And hopefully the lead is still not molten. Oh, there it is. Definitely got a little bit of graphite on the top from the fresh crucible. Well, that sure took a long time. Here we go. We got our button. Our nice little gold bead right there, if you can see that. It's 20 degrees out here, dark. But look at that. We got a beautiful, beautiful little gold bead right there. So let's see if we can pry that out. Hold it. Ooh, it's gonna pop. There we go. Got it. This is still blazing hot. There she be. Look at that. Let that cool down quicker right there. We chiseled that gold out of the vein. Here's the bead from the first sample area, which was the second smelt. 2.056 grams. And our second bead, which is from sample number 2, the second area we chiseled out, and in this case it was the first smelt. 0.344 grams. Yielded 13.7 grams per ton in the first sample area. Sample area number 2 is 2.29 grams per ton. Sample area number 1 with the larger button, where we're getting close to ½ ounce per ton, I had this professionally assayed, sent it into an assay lab, and the ore came back at 1 ounce per ton. It's possible that our rudimentary gravity concentration methods for this ore is losing a lot of gold, and it's also possible that we have a higher sulfide content than we realize, and the ore may require roasting.